Hey everyone, welcome back to the channel. Today we are officially kicking off our LeetCode review series, and there is no better place to start than where we began, which is number one LeetCode problem called two-sum. We're going to break this down using the REACTO framework to keep our thoughts organized and interview ready. Let's dive in. First step, let's read and repeat the problem to make sure we actually understand what it's asking. We're given an array of integers called nums and an integer called target, and our goal is to return the indices of the two numbers that add up to the target. First things first, the problem states that there is exactly one solution, that we may not use the same element twice. We can return the answer in any order. When we are in an interview, it's not just about reading the text out loud, but taking this time to slow things down so that you are not making any assumptions and we are able to clarify things with the interviewer to make sure that our solution can account for as many cases as possible. So some of the questions that we can ask here are, can the numbers contain negative numbers? And is the array guaranteed to be unsorted? And how large can these arrays get? Will it fit into memory? We'll start with example 1. Inputs are numbers array that has 2, 7, 11, and 15, and the target is 9. So if we are trying to get two numbers that add up to 9, it's pretty clear that we just add 2 and the 7, and their indices respectively are 0 and 1. So all we have to do is return 0 and 1, and note that this is in like an array. Same thing here. The inputs are thankfully short, 3, 2, and 4. And to get to target, which is number 6, we would have to add 2 and 4, and their respective indices should return 1 and 2. Number 3 is a little bit different because it's an edge case where the values on those indices are the same, but we have to make sure that our code does not repeat itself just because the values are the same in order to reach the target. One final edge case that I have to mention involves the negative numbers, and we have to ensure that our code doesn't just abandon any negative values just for being small, because in this case you can see that even though we have negative 3 for the target of 6, negative 3 could pair up with number 9 in the third index or fourth index to add up to the target of 6. Moving on to the approach. There are two main ways to tackle this particular problem. Is the brute force way versus the, quote unquote smart or the correct answer approach. And first we're going to take a look at the brute force. It's very straightforward. We pick a number, and then the first loop on the outside would iterate through the first number, and then the inner loop would then iterate through the second set of numbers to compare to see if they add up to the target number. And the issue with this particular problem is its time complexity. And its time complexity in this kind of nested loops translate to O of n squared. If the array has 10,000 numbers, your computer would have to do up to 100 million operations to complete this task. Um, Thankfully, the space complexity for this problem is O of 1 because we aren't storing any data in due process. I realized that I was talking about different approaches which already address the optimization part of the REACTO that we were going to discuss later. So I'm going to dial back and do the coding part, REACTO. And then we'll talk about coding for the optimization part afterwards. So here we have the brute force solution. Going line by line, we have the solution class where we start with the function declaration. Return type is going to be an integer array, and the function name is toSum. And the two parameters we're working with, integer array called nums and another parameter called target that we're trying to meet. So we have to find the target from the nums integer array. First thing we're going to do is loop through the numbers array for its length times, starting from the very first index. And then for each of those, we're going to compare it with every other element that is not itself. That is the whole purpose of I plus 1. And then if the compared number is a complement, which you compute by doing the target minus nums.i or nums.i, then you can return by creating a new integer array and putting in those two numbers for having found the complement, and you don't have to go any further. That's where you end everything. Now we are going to test the code that we just saw for the brute force method. Let's take a look at the test case of nums array that contains 2, 7, 11, and 15. So we call the function. If 7 is equal to 9 minus nums.i, which in this case is 2, then all we have to do is create a new integer array with values of I that is 2, or the index itself that we're returning would be 0 and then 1. So we see that. And in case of 2, we start with 3. So 3, we compare it to what? If 2, because j is 2 in this case, is 2 equal to 6 minus target, 6 minus nums.i, which is 3, so 6 minus 3, is that equal to 2? No. So we move on, and now I is 2 and j is 4. What do? Is 4 equal to 6 minus the value of I, which is 2? 6 minus 2 is indeed 4. So then we return the indices 1 and 2 as shown below. And finally, case number 3, we only have 2 here and the target is 6. So I is 3, or the value of index I is 3. The value of index j, which is I plus 1, is 3. So if 3 is equal to target 6 minus 3, then return those two, so their indices, and we see that So we can see that brute force's solution is working fine here. Now the evolved version of our brute force approach would be the 2-pass hash table, where you loop through the whole array once to fill up the dictionary, and then loop through it a second time to look for the complements, which is shown right here. We're going to skip this one and go straight into the more efficient version, where it sort of does this already, but even more efficiently. As we are iterating and inserting elements into the hash table, at the same time we are also looking back to check if current elements complement already exists in the hash table. And if it exists, we have found the solution and return the indices immediately. So going line by line, again, we start with the function or class, whatever you want to call it. And here we're starting with the dictionary declaration, which by now I should know by heart, and I think I can say I do. And then we iterate through the numbers array. And before we dive in, we set the complement variable as the target minus the value of the number in index I. And this is the step that checks it on your way of completing this dictionary. If the dictionary contains key of the complement, then you have already found the answer. I think this part can be a little bit confusing. So to break it down, we have the complement that we have to find, right? And in our dictionary called map, we are saying that we have already ran into this complement earlier in the array, or have we? Right? That's the whole contains key question. And if it does, then we make the answer integer array using that complement index with the index that we have. It's so confusing to say this. So the nums I is giving us the actual number, and the map part is saying that we're using that nums I as the key for our dictionary. And we're saying that we're going to store our current index I as a value for that key. A bonus stage is if the interviewer were to throw a curveball and now tell you that the array nums is already sorted, then that changes a lot. So originally with an unsorted array, the cost for us to use the hash map was O of n space complexity, because we have to store elements in memory. But now, if the array is sorted, what we can do instead is use the two-pointer technique, which drops our space complexity to a perfect O of 1, while keeping our time complexity at O of n. So rare occurrence of, not having to trade either of them, but obviously it probably did cost them to sort the array. So how do we do that two-pointer mechanic? assuming that the numbers are sorted in ascending order, we know that the smallest numbers are on the far left and the largest numbers on the far right. So instead of making a whole dictionary to remember the past numbers, all we have to do is place 2 pointers or index marker, one on the left side, other on the right side. So left one would be index 0, right side would be num.length minus 1 to signify that it's at the end. And what we do with that is that we add those values, L and R, together to see where we stand compared to our target. So every time we compare the sum of the L and R, we'll get one of the 3 results. Perfect scenario would be that those equal to sum. And all we have to do is return L and R as an array for the answer. A second scenario is that the sum is too large. Maybe we do get a sum that is way bigger than our target, right? Then all we have to do is move our right pointer to the left so that the overall sum drops. Versus if the sum is too small, then all we would do is move the left pointer to the right. Right? This kind of reminds me of the sorting algorithm that we learned this week. I believe it was bubble sort? Or yeah, I think when we were implementing bubble sort, we had this kind of idea of moving left and right bounds, which is interesting to see it here. So going from unsorted array to a sorted array, the only thing changes is the space complexity, because both are fast in terms of time complexity, but unsorted array would cost heavy memory usage due to hash map relative to the 2-pointer method, which is not going to be storing anything. That was my first attempt at trying to make a REACTO formatted to some video that reviews the problem. It was a lot of editing, trying to explain it better. Not that I've done a better job necessarily, but it was difficult to do that. I think that just shows that I'm pretty far away from being able to do it so fluidly where I would like to be. But definitely allowed me a little refresher for the brute force method that I used, and trying to understand the optimal solution. I think I'm a step closer to being able to explain it to someone brand new to this. I feel that I am still taking too long to explain certain things, because this is me having all the answers in front of me, right? Sure, I did point out some side notes of things I felt here and there, but maybe I should look up some videos on how the real interviews are done and how much time people are expected to be given at each stages of the REACTO format, and maybe I can try to compare ways to optimize this process. But thank you for watching. If I made some mistakes here and there, feel free to point them out. And I hope some of you learned a thing or two.